Have you ever stopped to think that some, well, really ancient, almost mystical practices might actually hold the keys to our modern world? Today, that's exactly what we're exploring. We are diving deep into alchemy. It's often just seen as that old quest to make gold from lead.
Right, the classic image.
Exactly.
Yeah.
But our mission today is to uncover its really profound and I think quite surprising influence on, well, the very foundations of modern science.
It's a fascinating journey, it really is. Alchemy wasn't just one thing. It was this complex mix of philosophy, spirituality, and importantly, early hands-on experimentation.
Right.
It spans from antiquity right up into the early modern period. And yeah, look, a lot of the core beliefs are discredited now. We know you can't just zap lead into gold like
That's
that.
true.
But the critical thing for us, for you listening, is how its theories, its practices, undeniably shaped how modern chemistry developed, and medicine too, and even the scientific method itself.
And that's the real aha moment, isn't it? How this seemingly magical, fringe pursuit actually laid the groundwork for the super rigorous science we rely on today. It's kind of mind-blowing when you dig into it.
It really is.
So here's where it gets really interesting. Let's start by looking at some of alchemy's core theories. Because even the ideas that sound, well, pretty wild to us now had a lasting impact. Let's talk about the big one. Transmutation of metals.
Ah, yes, the magnum opus for many alchemists.
They genuinely believed, didn't they, that they could take something common, like lead, and transform it into something precious, like gold, usually involving the legendary Philosopher's Stone.
They absolutely did believe it, and while it sounds impossible to us, and it was impossible the way they imagined it, but think about what pursuing that impossible goal meant.
Okay.
It meant decades, sometimes lifetimes, of relentless, systematic experimentation. They were trying everything, mixing substances, heating them, cooling them, meticulously observing reactions.
And so just constant trial and error.
Constant trial and error, driven by this unachievable dream, ironically. And it's that process, that hands-on work, that paradoxically laid the foundations for modern metallurgy and, inorganic chemistry.
That's such a key point. The goal might have been fantasy, but the process became science. And this Philosopher's Stone wasn't just about gold, right? It tied into other grand ideas, like the elixir of life.
Exactly. The stone was often seen as this dual-purpose wonder substance, yes, transmuting metals, but also potentially granting immortality or perfect health.
The ultimate cure-all.
Pretty much. And
Yeah.
that pursuit, finding this universal panacea, pushed them even harder into research on purification, distillation, crystallization, all these fundamental chemical processes.
Processes we still use today.
Absolutely. Techniques that are vital in every modern lab every single day. It's quite fascinating, isn't it? That the quest for the impossible drove the development of these very real, very practical, foundational techniques.
It really is incredible. But their thinking wasn't just about making stuff. They were also grappling with bigger questions, like what is stuff made of?
Which brings us to the elemental theories.
Right, the underlying nature of matter.
For a long, long time, you had Aristotle's 4 elements dominating Western thought: earth, water, air, and fire. Now, obviously, we know that's not how elements work.
It's an outdated model.
But what was the impact of thinking that way? Well, it encouraged people to try and classify substances, to look for fundamental principles within matter. It pushed them to categorize, to try and understand the basic building blocks. And you can see how that line of thinking eventually influences later ideas like atomic theory.
And building on that, you get figures like Paracelsus, the physician, who introduced his own model of the 3 principles, or tria prima.
Okay, what were those?
Sulfur, mercury, and salt. But not literally sulfur, mercury, and salt as we know them today. It was more symbolic. Sulfur represented, sort of, combustibility, the fiery principle.
Yeah. Mercury represented volatility, the spirit, the fusible aspect. And salt represented solidity, the non-combustible body.
Interesting. So less about physical elements and more about properties.
Exactly. It was an early attempt, really, to describe matter based on its underlying chemical behavior, not just what it looked like or felt like. It was a really significant step, conceptually, moving beyond just observation towards function, and it definitely influenced the chemical revolution that came later.
So they had these grand theories, these, almost cosmic goals. But the key thing, as you said, was the hands-on work. Alchemy wasn't just armchair philosophy. What did they actually do in their labs, their workshops that shaped science?
Oh, a huge amount. And this is where we see the roots of the experimental method taking shape. Alchemists, many of them anyway, were surprisingly meticulous.
Really, despite the mystical side.
Yes. They often kept detailed records of their experiments, what they mixed, what heat they applied, what happened. They developed and refined essential lab techniques like distillation, calcination, sublimation, things that require careful procedure. And critically, they observed closely. This whole empirical approach, learning by doing, watching the results, writing it down, that was absolutely fundamental to the rise of the modern scientific method. It really makes you question, doesn't it, how much of what we call science started in these places we might label unscientific.
Yeah, it blurs the lines. That rigor, even if the goal was flawed, was maybe the most important legacy. Did they, document failures too? Was that useful?
That's a great point. Yes, documenting what didn't work or didn't produce the desired result was just as important. It built up this body of knowledge, flawed as it sometimes was, that others could then build on or argue against. And it wasn't just methods, it was the tools themselves.
Ah, the actual equipment.
Exactly. Alchemists developed or seriously improved lots of laboratory tools and techniques. Think about crucibles for high-temperature reactions, furnaces for sustained heat, alembics.
Alembics, those are the early distillation things, right? With the curvy necks.
That's them. Early distillation apparatus. Imagine trying to do modern chemistry without a way to heat things strongly or separate liquids cleanly. We owe the basics of that equipment to the alchemists. They're direct precursors.
I'm sorry, dreaming of gold and instead inventing lab glassware. So next time you see a chemistry setup,
you're seeing a lineage straight back to those alchemical workshops.
Yeah.
And the influence didn't stop at chemistry equipment. It went right into medicine and pharmacology.
Okay, how so?
Well, Paracelsus, again, is key here. He famously rejected the old Galenic system of medicine.
The four humors thing, blood, phlegm, etc.
That's the one. Been dominant for centuries. Paracelsus said, basically, forget that. Let's use specific chemicals to treat specific illnesses. He championed what we'd now call iatrochemistry, or chemical medicine.
That sounds much more modern.
It was. And crucially, he stressed the importance of dosage. He's famous for the saying, the dose makes the poison. The idea that whether something heals or harms depends entirely on how much you use. That directly foreshadows modern toxicology and pharmacology. It was radical.
Wow. Okay, so tools, medical ideas. Well, what about how they communicated? All those weird symbols.
Ah, the symbolism. Yes, it looks incredibly arcane to us now, doesn't it? Those intricate symbols and allegories. But that complex symbolism eventually evolved into scientific language.
How did that happen?
Gradually. Over time, there was a push towards more clarity, more systemization. It wasn't overnight, but the need to communicate findings more reliably led towards standardizing terms. A process that chemists like Lavoisier later really formalized, giving us the basis of the chemical nomenclature we use today. But the roots are there in trying to represent substances and processes.
So even the language evolved.
Yeah.
And they actually found new stuff too, right? Not just technique.
Oh, absolutely. We can't forget the actual chemical substances and discoveries. Alchemists discovered or were the first to purify and systematically study many important substances. Things like alcohol through distillation, strong acids like nitric and sulfuric acid.
Wow, sulfuric acid, that's heavy-duty stuff.
Indeed. Also, phosphorus, ammonia, various metal alloys. They weren't just theorizing, they were discovering the building blocks of chemistry. So yeah, when you see a chemist handling sulfuric acid, there's a direct line back to an alchemist's furnace.
It paints such a different picture. It wasn't like a light switch flipped from alchemy to chemistry. There were people bridging that gap.
Exactly. It was a gradual transition, and there were key figures who really embody that shift, standing with a foot in both worlds, so to speak.
Who should we know about?
Well, we've mentioned Paracelsus a few times. Absolutely pivotal in pushing for chemical medicine, rejecting the old ways. Then there's Robert Boyle.
The skeptical chemist?
That's the one. His book was hugely influential. He really argued for defining elements based on experiment, separating chemistry from the more mystical aspects of alchemy. A massive step towards chemistry as a distinct science.
Okay.
And then, perhaps the most surprising for many, is Isaac Newton.
Newton, the gravity and physics guy. He did alchemy.
He did, extensively. He wrote far more on alchemy and theology than he did on physics or math, actually. It shows just how intertwined these pursuits still were, even for someone considered, the father of modern physics.
That's astonishing. I had no idea.
It surprises many people. And we should also mention earlier figures like Jabir ibn Hayyan, sometimes called Geber in Latin texts, an incredibly important Islamic alchemist from around the 8th or 9th century.
What did he contribute?
He documented so many chemical processes with great clarity, distillation, crystallization, oxidation. His systematic approach and practical knowledge were hugely influential on later European alchemy and chemistry.
So a real international, centuries-long evolution.
Definitely.
Okay, so let's try and wrap our heads around this fundamental shift.
Yeah.
We start with alchemy steeped in mysticism, right? Mixing spiritual goals, astrology, philosophy.
All woven together. But the crucial thing to grasp, the real takeaway for you, is that within alchemy, there was this gradual growing emphasis on observation, on trying to replicate results, on refining theories based on what actually happened. Even if their ultimate goals were off, the methods were slowly becoming more scientific.
Right.
And this slow shift, this growing rigor, is incredibly important because it really did help kickstart the scientific revolution. The principles of modern science didn't just appear out of nowhere. They emerged from this complex history.
It's amazing when you lay it out like that. You can draw direct lines, can't you? The quest for transmutation.
Yeah.
Well, that curiosity about changing elements evolves into atomic theory and eventually nuclear chemistry.
Precisely.
Those hands-on laboratory practices become the bedrock of scientific experimentation and modern lab techniques.
Mm-hmm.
The weird symbolic language morphs into systematic chemical nomenclature. The kind of mystical medicine ideas paved the way for pharmacology and toxicology, especially with the dose concept.
Directly.
And even those ancient elemental theories, however wrong, sparked the thinking that led eventually to the periodic table and modern chemistry.
You've got it. It's a clear, though complex, lineage.
It really does feel like a shortcut to understanding where so much modern science came from, looking back at alchemy this way.
I think so. And there's a whole journey from alchemy to chemistry. It really reminds us of something important, doesn't it? Even when our starting goals seem, well, far-fetched or based on flawed ideas.
Like turning lead into gold.
Exactly. The methods, the tools, the processes we develop while chasing those goals can end up being revolutionary in their own right. They can lay the groundwork for discoveries we never initially imagined. It really makes you wonder what seemingly fringe or out there ideas today might be quietly, unexpectedly shaping the science of tomorrow.
That is a fascinating thought to leave us with. What are the alchemies of our time? A really profound question. And on that note, our deep dive into alchemy's surprising and enduring legacy draws to a close. Thank you for joining us on this exploration.